Alright, this should be a fairly quick lecture. It's just introducing you to lenses and lens systems. And the nice thing about lenses is they work almost exactly the same as curved mirrors. So it's just have to remember convex versus concave is opposite. Alright, so you see here a convex lens, light comes in parallel, it brings it together. So a convex lens acts like a concave mirror. It focuses the light. So it's sometimes either called a positive lens or a converging lens. You can kind of see the light coming together. That's why it's converging. And then a diverging lens is concave. It goes inwards, and it's sometimes called a negative lens or a diverging lens. Right, so three names that are given to it, given to different lenses that have the same basic properties. Right here, same difference. You know, two lenses with 20 centimeter focal lengths, positive lens, the light focuses on the opposite side because it's refraction instead of reflection. So refracting light goes through. So we say that a positive focal length is on the opposite side because it goes through. And then a concave lens is a negative lens because it has the focal length in front of it. It doesn't actually focus the light to a point. It acts as if it's spread out from that point. So it's diverging. There are different sizes. This would be a concave, a convex lens, a positive lens. This would be actually a negative because of the shape of this here. Different, there's a positive and then a negative. Different shapes of the same thing. So a lot of people with glasses, most people with glasses have lenses that look kind of like this one here. But depending on your prescription, you'll have different things. Right, all kinds of strange names for fairly simple ideas. All right, don't focus too much on this, but I want you to have it just for reference. It's called the lens maker's equation. It tells you what the focal length of a lens is depending on the radius of curvature of the two sides of it. So n is the index of refraction of the material that gets used. Like if you tried to make a lens in air out of air, it really wouldn't be very useful no matter what shape it was. You'd have a 0 there. But 1 over R1 is the front surface of the lens, and R2 is the back surface. So as it's going in there, ooh, fancy animation. As it's going along there, the light is refracted so that it goes to a specific point as long as it comes in parallel. And I'm sure this is the application of converging lenses or positive lenses that many of you are familiar with. I know I decided to, I didn't want to have one of those things where PETA gets mad at me if we show burning ants on a video, so that's just burning newspaper. All right, so the same equation applies. 1 over f is equal to 1 over p plus 1 over q. Magnification is the height of the image over the height of the object. Equals, oh, there should be a negative sign there. Oh well. Negative q over p. Same equation. So convex lens, you have an upright object, it creates an upside down real image as long as you're outside the focal point. If you're inside the focal point, so here's your object, you create a virtual image. It's like looking at the magnifying glass part of a magnifying glass, if that makes any sense. All right, then negative lenses, diverging lenses, will always create virtual images and they'll always be smaller. So your virtual image, here's your object, here's your smaller virtual image. Light's not actually focused on that point. You couldn't project an image onto a screen using a single concave lens. All right, this is very similar to the what do I want to call it? The table we had before, but they're only concave and convex lenses. We don't have flat lenses. That's just a piece of glass. So if we're outside 2 times the focal length, we get a different thing as if we're between twice the focal length and the focal length, and then inside the focal length. I'll let you, if you need to copy this down, you can just pause it, move on. And then multiple lenses. We'll do several examples with multiple lenses. There are a lot of systems that we use are actually, just one lens doesn't give you the whole story, but you can actually use multiple lenses to create an image of something. And basically what you do is you treat the image created by the first lens as the object of the second lens. It's just a way of, you just have to solve it twice, unless they're touching, and then it actually, you add them kind of like series or parallel circuits. And I think that's it for this week and this week's homework. I'll be posting, hopefully later today, stuff for Wednesday's lecture so you can get ahead. All right, thanks a lot.